Testing 1 2. Getting him as a woman. Fuck it. I was wondering, Bianca, if you can hear me. You should have a microphone somewhere, or if you're working from a laptop, you must just activate the microphone. There should be a setting there somewhere. Can you hear me? Just send me a little note or a text on WhatsApp if you can hear me. What we need to do is just get that microphone going, otherwise the class is not going to work very well. Okay, there's a video. Your video is on, that's fine. I just need you to get the microphone going. There should be, I'm not sure if you're on a laptop. I'm going to give you a call on WhatsApp quickly. Just make sure you can get that going. Hi, morning, Bianca. The mic. Okay, are you on a laptop or PC or what? Or phone? Okay. On your phone, there should be a setting as you logged in that that you allow. I think if you we're in the school now, and you swipe the screen left or something. Somewhere there's a drop down menu that says join with audio or allow audio or something like that. Okay. Okay. I'll end this call. Okay, your mic's still not there. I'm going to help you somehow. I can see your video. I think your microphone is not activated in your settings. It's not just a Zoom thing. Maybe what you should do, just log out again and just Google how to set up your mic. You'll have to go to your settings and apps and notifications and permissions to allow Zoom to access your mic. Do you understand that? Just exit again. I'll give you 5 minutes. And then you go to your permissions. So you go to your phone settings and then your permissions, because your mic is not, your phone is not allowing Zoom to access your mic. I'm back in 2 minutes.
Okay, I think I got it.
I see your mic. You're there. Can you hear me?
Yes, I can. I got it.
Wonderful.
I figured it out.
Okay, great. So what was it? Permissions.
Pardon?
What was the wrong?
Oh no. So it kept asking me whether I wanted to use like Wi-Fi or I needed to dial in, and so I just pressed Wi-Fi, and then it's allowed me to unmute my mic.
Okay, let's quickly look at
Yeah.
the stuff that you've done. Look, we can't cover
Yeah.
everything. I just want to really find out what you're struggling with, so we can.
Okay.
So you done.
So I did go through my books last night. So this term 1, we just had to do physics because that's what I test, and my assignment was on.
Yeah.
But my teacher didn't really do basically anything with me. So we were still on vectors, and my assignment is on the Newton's second law. So if we could go over Newton's laws of motion, that would be great.
Okay, that is like 5 lessons. It's a lot of work.
Okay. How many?
Can we just make a tick next to vectors?
Yeah, of course.
And then we have Newton 1.
Yes.
2 and 3.
Okay, cool.
And you have the Newton's universal law of gravitation.
Yes.
Okay, but the problem is normally Newton 2.
Okay, yeah, because that's what my assignment is on for term 1.
When must that assignment be finished?
Well, Auntie Judy said to me that I can do it within like the first 2 weeks of term 2. So that like all my all my classes can be done.
All right. Okay. That
Yes.
might be a problem because remember, you're also getting new work to do.
Yes, I know.
All right. So
how many times do we have classes?
We have normally what we do, Bianca, is you have once a week a class for an hour. And that class is focused mainly to help you with the stuff that you were doing this week. So say, for instance, you're busy with Newton 2, and there were a couple of things you didn't understand, then we do it in that class. Or you say, look, there's nothing I've got that's bothering me. Let's start with this or that work. Then I explain the work. But if you are going to catch up on Newton 2 and do new work, you might want to do 2 classes per week. But that's
that's fine.
Yeah. But that has a cost implication involved, obviously. You must remember that.
Okay.
So you're paying for, next term you'll be paying for 1 hour per week lecturing.
All right. And how much would that be?
That works out to about 1,600 Rand for the whole term.
Okay. I'll speak to my dad about it today when he gets home.
We can always play it as you need. I mean, if you don't need extra help, then obviously we're not going to do it. But I'm just, if you don't understand Newton 2 yet, then you're actually far behind.
Okay.
All right. So this is all I'm saying. Okay, but anyway, do you have specifics on that, or do you just want to start with Newton 2?
I would like to start with Newton 2, please.
Right. So Newton 2, there's a definition that you'll have to go and learn.
Yes.
I'm not going to teach you that definition because I want you to copy the one exactly as it is in the book. But what it boils down to, what they're saying, if you apply a net force or an imbalanced or a resultant force to an object, so for instance, there's a box, and you're applying a force, a net force, or do you use F-res? Which one do you use, net or res?
We use net.
You apply a net force to an object. That object will accelerate.
Oh, yeah, of
direction
course.
of that force, and that acceleration is directly proportional to the force. What it means, if you increase the force, then acceleration
increases.
If you decrease the force, the acceleration will decrease.
Okay.
And the acceleration is also indirectly proportional to the mass of the object.
Yeah.
So if you decrease the mass, the acceleration will increase. If you increase the mass, acceleration will decrease.
Okay.
Inversely proportional means if you increase the one thing, the other thing goes down. So think of it as a shopping trolley. If you push, if you continue to exert a steady force on that trolley, it will start accelerating. Okay, the
Yes.
acceleration depends on the force that you apply. The higher the force, the higher acceleration. And it also depends on the amount of stuff you've got in the trolley. If your trolley is quite
Okay.
light, it will accelerate fast. If it's heavy, it will
Yes.
accelerate slow. Okay, but
All
we've
right.
got this formula.
Pardon?
F net equals ma. That's your Newton 2 formula. The resultant
All
force
right.
is a net force equals the mass of an object times acceleration. But now the net force is just a combination
Yes.
of all the other forces.
Okay.
Okay, now I want to test you quickly and see how many forces can you see. Can you basically draw free body diagrams? Okay, there's a box with a mass of, let's say, 10 kg.
Yeah.
Someone is pulling the box to the right with the applied force, and there's a frictional force of, let's say, 8 Newton. Doesn't matter what's the value. Free body diagram. You're going to guide me to draw a free body diagram of all the forces on the box.
I don't remember how to do those.
Okay. There's a force. The easiest one is called the normal force.
Okay.
It's called N or Fn.
Yeah.
And that's the force
Yeah.
basically that the tabletop is exerting upwards on the box. It prevents the box from falling down
Okay.
through the table. Then there's also a force due to the gravitation of the Earth. It's called W or Fg. Which one do you use?
Okay. We use Fg.
Okay. And then there's a force to the right. That's
Yeah.
F. It's called applied force. And then we have a force to the left called friction.
All right.
That was quite easy.
Yeah, it was.
Okay. There's nothing we need to calculate. They can ask us to calculate the acceleration, but we're first going to do a bit of diagrams.
Okay.
All right. Then let's do this. There's another box, and there's a rope and a smaller box. And we're pulling this system to the left with a force.
Okay.
There's some tension in that rope. This is called A and B. And there's friction here and friction there.
Yes.
Okay. Free body diagrams of both boxes. Box A.
All right, I'm just...
Okay, you're gonna make a small drawing yourself, make free body diagrams of both, and then we work together to get the answer. I just want to get those drawings. It's gonna take just a 10 minutes or so just to get some of the drawings going, because that's quite important.
Yeah.
You can't do the drawings, you can't do the sums.
Okay. Just give me a second.
Okay, no problem. So you've got another week of holiday.
Yeah.
It's a lot of work this time.
Yeah.
A lot of work that you're doing.
Yeah. Sorry, we didn't start with any of these drawings at all.
Okay, no problem. There's a normal force upward called N.
Yeah. Yeah.
So then there's a force downwards because of gravitation. Then I have applied force to the left, F. This is on the A block.
Yeah.
Then I also have something to the right, T, tension. The rope. The rope is pulling the block to the right. There's another force to the right, friction.
Yeah.
Cool. Okay, now B. There's the middle. Upwards, I have a force called normal.
Yeah.
Down, FG.
Yes.
To the right, friction.
Yes.
To the left, T.
Yes, and to the left, tension. Yes. Okay, I get it.
Okay, cool. There's nothing we can calculate here. Nothing is asked. Right.
All right.
Okay. Last easy flat surface sum. Then we're going to make an angle. Okay, there's a weight.
Okay.
Mass 1. There's another block called mass 2. And this is a rope.
Yeah. All right.
Friction.
There's tension in the rope.
Yes. Okay.
Yeah.
I want the free body diagram of M2. Help.
Okay. All right. So the up would be normal,
Yes.
right? Okay. And then the bottom one would be FG.
What? Yes.
And to the right, would it be T?
For tension in the rope, yes. And to the left?
Yeah. And then to the left, would it be F?
Friction. Yeah. Small f or long f. Doesn't matter how you see it, but it's a
All
small,
right.
not a capital letter.
Okay.
Okay, and then M1.
All right. M1. So would up be N?
No. N can only be there if something's on
What
a
would it be?
N means
All
the
right.
normal
So
force
would
means
it
it's a
be
solid
like
surface. The T is up because the tension in the rope is going up
okay?
and down.
Yeah, I thought as much, but I didn't. It would be FG.
FG. Very good. Okay.
All right.
Now
Is
we
that
have
it?
no. Now we have a like a surface on an angle of say 30 degrees. There's a block.
Mm,
Let's
yeah.
say the block weighs 8 kg.
Yeah.
And we have friction there. Right, now I want you to draw free body
Okay.
diagram. The block, yeah, doesn't matter if it's moving or not. No one's touching the block. It can be sliding down or standing still.
Yeah.
All right, now.
Okay. Would up be? Yeah.
So
Sorry.
what's the normal? The normal is up perpendicular to the surface, eh?
Oh, okay. Okay. Right.
Very important. I'm just going to try and draw a straight line because you're going to be using a ruler in exam. So that's the force
Yeah.
normal. It's perpendicular upwards from the surface.
Yeah, because it's on an angle.
Yes. Then we have weight
Yes.
or FG. And then we have friction.
Yeah.
Okay, but now very important. This is correct. This is 3 marks, full marks, in other words, in exam. This one is 3 marks. This is
Yeah.
like the one way of drawing it, method 1. I want you to draw it this
Yeah.
in a test though. The normal is still going to be in that direction.
Yeah.
And the friction towards back. But I want you to take
Yeah.
FG force and I want you to convert that into components. In other words, I'm going to make a FG parallel force. It's the force parallel to the surface because of the gravitation of the Earth. And
Okay.
FG perpendicular. So basically what you've
Okay.
you converted this gravitational force is like the resultant force of these two vectors. FG parallel,
Yeah.
FG perpendicular. And that makes, so this is method 2. Both of them are accepted in exam. But this one makes your sums easier.
All right.
Your Newton 2 calculations much easier. You can't really do it any other way. That is the right, if you draw that free body diagram that is in black, it's going to make doing your calculations much easier.
Okay.
You must take a note of this somehow. So this is, I'm going to,
Yeah.
are you taking notes or screenshots or what?
I am taking notes.
Okay. So both is correct. And for the second one, you're also only getting 3 marks. 1 mark for those two. That's divided into components. Okay, the next thing you need to do, you need to use these free body diagrams to calculate friction.
All right.
Okay, so I'm going back to a flat surface. Well, it's not that flat. There's a box, and it weighs 8 kg. Now, sometimes they give you the friction as 6 newtons. Okay.
Yeah.
But then you don't have to calculate it. So in other words, if
Yeah.
I'm pulling the box that way with 10 Newton, then I can work out the acceleration is very easy. F net equals MA. Now we choose the movement towards the right is positive. So my
Yes.
free body diagram, I'm just going to do a Mickey Mouse sum just to show you what you would have done if you've got the friction.
Okay.
So this is your free body diagram.
Yeah.
And the net forces are the forces parallel to the surface.
Yeah.
And all you're going to do is you're going to add them. But because you've chosen towards the right as positive, you're going to say
Yes.
force plus negative friction, because friction is to the left, is the mass of the object times acceleration. Now the force
All
applied is
right.
10 minus the friction, and that gives me 8a. So that is 4 equals 8a. So 0, 5 is a. Therefore, the acceleration is 0,5 meters per second squared to the right. That was
Okay.
easy.
And just yeah, that was
You've
very
done that.
easy. Yeah.
Okay.
Okay.
So we're going to do exactly the same thing,
Yeah.
but they're not going to give you friction now. They're going to give you a coefficient of kinetic friction.
Okay.
Have you seen that?
No, I unfortunately haven't.
Okay, so now they haven't given you friction. That value is just an indication of the roughness of the surface. The higher
Yeah.
the value, the rougher the surface and the harder it's going to be to pull it.
All right.
But the sum is
Okay.
exactly the same. The only thing
Yes.
okay, so your sum is going to look like this. F plus negative friction is 8a. The problem is you don't have the friction now. And you have to go.
Okay.
Now, friction can be calculated in various ways. One of the equations,
Yeah.
the kinetic friction, kinetic just means friction because of movement, is
Yes.
the mu value times n.
Okay.
Now I have to indicate that on my diagram, n and
Yes.
f is exactly the same
All right.
because they balance one another or they're in equilibrium. So now I have to say
Yeah.
n plus a negative fg is 0. That means they are in equilibrium. So the normal force is exactly the same as the gravitational force. Therefore, the
Yeah.
normal force is mg. Do you know where I get mg from? Because fg is mg.
Yes, I
Okay.
do.
So now I can continue with the sum and say, okay, therefore the kinetic friction is the mu value times mg. And
All
the
right.
mu value is 0,2, and the mass of the object is 8, and gravitation is 9,8.
Okay.
So
Yeah,
I
of course,
calculated
of
my
course.
calculator, which I don't have. What's that?
Oh, I don't even know where mine is.
Okay, I've got one now. So that's 15,68 Newton.
Okay.
So the force applied is 10 minus,
Yeah.
oh damn, my friction is a bit high. The force applied wasn't big enough to overcome 15 newtons of friction. So what I'll have to do is just change this mu value. Stupid.
2.
0,01.
Okay.
Otherwise, I'm not going to have enough force to overcome that friction.
Yeah.
0,01. Right, let's change that. Right, now I have very little friction. 0,784 Newton.
All
0,784,
right.
and that is 8a. 10 minus answer. And then I solve that equation.
Yes.
I don't have that answer. 10 minus 0.784. Okay, there we go. Is 1,15. A is
All right.
1,15 meters per second squared to the right.
Okay. So.
Okay, so there's a lot of other stuff on friction that you'll have to know and go and study.
Yeah.
There's kinetic and static friction. Kinetic just means it's moving, and then you get static friction, which means it's standing still, and then you get maximum.
Yeah.
It's a theory that some theory that you'll have to learn.
Okay.
Okay, so you'll be able to do something like this.
I will, yes.
getting this formula.
Yes.
All right.
I definitely will.
Right. Next surface. We're back with a 30-degree angle. There's a box. This box is 10
Yeah.
kg.
Okay.
Let's say it's in rest, so it's standing still.
Yes.
And there's a coefficient of
Yeah.
static friction, which means standing still, of 0, let's say 3.
Yeah.
Okay. Free body diagram.
Okay, so would it be up in? No,
Yeah.
no, no, it would be it would be slanted
Yeah,
in,
because
and then
perpendicular to the surface, then.
yes, 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 yes. And then it'll be to the right, that you'll draw like a line, and then it'll be FG. No, it'll be F.
For friction.
Yeah, and then like a little bit like to the left of friction, we would have FG.
There.
Yeah.
Okay, that's correct.
Okay.
But that one's not going to help you in the sum. Look at
Yeah.
the one. This is the red one is accepted. The blue one is also accepted. But you'll find out quickly now the difference between the two. So the blue one is the one that I prefer, and you'll find out now. I'm going to take that gravitational force, and I'm going to convert it into a component that is parallel to the surface, and in component that is perpendicular to the surface.
Okay, cool.
Right, now they're going to ask you, okay, fine. They're going to help you. The first question is just going to be, okay, what was the free body diagrams? Okay, so we've done that. The second question is,
Yeah.
what is the friction?
Okay. So,
There's two ways of doing it.
yeah.
Okay, very important. Okay, let's say method one. This is basically the method I want to stick. This blue free body diagram tells
Yeah.
you that because F net is 0, F net is 0. Why? Why is the resultant force 0? Because the acceleration is 0. Remember, F
Yeah.
net,
Because it's in resting.
yeah, is ma. If the acceleration is 0, then the net force is 0.
Okay, cool.
How good is your Afrikaans?
Afrikaans is quite good, but
Really?
I don't really understand it in maths.
You don't understand. If I give you questions in Afrikaans, will you be able to do it or not? No.
I will.
Really?
Yeah.
So what's acceleration in Afrikaans?
I don't know what that is, but I will use I'll use Google Translate and then I'll do it.
Okay. Right. Anyway, so in other
Will
words,
you be giving? Sorry.
I
Will you
can
be
give you a
giving
lot
me
of stuff.
homework?
Yeah, I should.
Okay.
Now, if you look at these two forces, they are the same because the negative force is 0. So if I pick
Yes.
up this equation and I choose downslope as positive, then my FG parallel force is positive and my
Yeah.
frictional force is negative. But very important, because I'm trying to find out what the force is, I'm not going to give it a sign. I'm just going to do that.
Okay. All right.
So the sum of the two forces is 0. Now, how do I calculate FG parallel? How do I
Would
calculate?
we use those other ones that we did?
Do you know how to
Those other I don't know how to calculate.
Okay, FG parallel is
Yeah.
FG sine alpha, and
Okay.
perpendicular is mg cos alpha. I can show you on diagrams why it's like that, but most students prefer just to learn it because I don't have time to redraw the diagrams in the test.
Yeah, I'll learn it, yeah.
Okay, so we've got the parallel, which is mg sine alpha, and that equals negative fs.
Yeah.
So mg mass is 10, gravitation is
Yes.
9,8, and then we have sine 30, and that is negative fs. And that would be 49, I think.
It gave, yeah, it is 49. You're
Right.
right.
So the static friction is 49 newtons upslope. Now, very important.
Okay.
This is
Yeah.
one way of doing it. There is another way.
Okay.
Method 2. If something is in rest, you can find out the static friction by just doing this. So if we have a block or something in just the object in rest. So if something is in a rest or in a constant velocity.
Yeah.
Okay, very important. Also, there's something else. Constant velocity. Then there must be no applied force.
Yeah.
Then tan alpha is mu.
Yeah.
I wonder if this one's going to work. So tan 30. What's tan 30? Tan 30 is not 49. No, so sorry. I don't need this. I've got all of that. You don't, sorry, this is not answering the question. This is another question. That was the only way of doing that one.
Okay, cool.
That's the only way of doing it. Okay, so that's the only method in this specific sum because we have the angle and the coefficient of friction, static friction,
All right.
which I think might be wrong. It's just thought of that these values is not necessarily correct.
Okay.
All right, so you're kind of happy with this?
Yes, I am.
Nice. Okay, so let's do another example. There's a 15-degree angle. There's a box. Someone's pulling it upwards.
Yes.
No, let's start with the easiest sum. No, this one is fine. Someone's pulling it upwards with a force of 80 newtons. And this box is 20 kg.
Okay.
The frictional force is 25 Newton. Just to check if that's going to work. Yeah, it's going to just work. Okay, first question. Free body.
Yes. Okay. So it would first, must we use your diagram or the one or anyone?
Anyone, but I'll prefer mine. Otherwise, you're going to struggle with the sum.
Okay. So it would be perpendicular N,
Very good.
and then it would the right hand side would be F,
Yes.
and then it would be FG2, right?
Yeah, you can
So-
use, this is your method, eh?
Yeah. No. The other one, your one. It's,
Okay.
isn't it like parallel?
Yes.
Yes. And then FG perpendicular.
And then you don't need this one.
No, you don't need that one at all.
Right, so that's good. Second one, I want to know what is the acceleration?
Okay, so would we use F net equals MA?
F net equals MA.
And then we would say,
How many of these sums have you done before, Bianca?
I think I've done like one or two.
Really?
I'm not too sure. Yeah. But it's way easier the way you explain it.
Okay.
Okay, so
You're
would we
learning
say
very
F?
quickly.
Thank you. I am a very fast learner, but it depends on how I'm taught
So
and how I,
choose direction is
yeah.
positive. Always choose direction before you do the sum.
Okay.
If you can choose the movement direction as positive.
All right, so would the right be positive?
Right up will be positive.
Yes.
Then F is positive.
Yes. And then we would say plus negative F.
G parallel.
Yes. Okay, so
Mass.
Mass is 20.
And acceleration, we don't know.
Yeah. Okay. So
What is F?
there.
80.
No, isn't F 25? Oh no,
Well,
sorry.
we missed something on the diagram. That's a big mistake. My side, my mistake. And yours, but mine primarily. We haven't put in any friction.
Yeah.
Look at the free body diagram. There was one leg missing. It was friction. So we have to add here a negative friction. There's 3 forces.
Yes.
We missed out on friction. Boom.
Yeah.
Okay, so the applied force is 80. Minus. How can I calculate the FG parallel component? Mg sine alpha.
Oh yes. Okay. So
that's
mass
negative
is 20.
I'm just going to write it in here. Sine
All
alpha.
right.
Minus friction of 25. And that is 20A. Good.
Yeah.
Okay, so I already have like 55 here. Because 80 minus 25 is 55. And then
Yeah.
negative mass, which is 10, I think. No, it's 20.
Yeah.
20 G sine 15. And that is 20A. So I have 55 minus 20, 9.8 sine 15.
Yeah. It gives us 4,27.
Okay. Although I'm writing 4,27, I'm keeping
Yeah.
all of that in my calculator.
Okay.
Otherwise, I'm
Yeah.
rounding off too quickly. So I'm just going to press on my calculator, divide 20. And then I'm only rounding off to 2 decimals, which is 0,21 meters per second squared upslope.
Yes.
Not bad.
Okay.
Okay, next one. We're running through a couple examples focusing on friction.
Yeah.
Right, there's a block on a flat surface. The block weighs 5 kg. I have a coefficient of kinetic friction of 0,2. There's someone else pulling on the block at an angle of 60 degrees. Is going to be too much. Let's make that 20 degrees again. And someone's pulling with a force of 30 Newton.
All right.
Okay, now, we haven't done one like this.
Okay.
Free body. Now you have to look. There's 2 ways of drawing free body again. One helps, the other one doesn't help. There's a normal force. Then there's F.
Okay.
That's correct.
Yeah.
Then we will have friction in this direction to the back.
Yes.
And then you can just draw in that applied force. Oh, it's not normal. It's a force. But again, this method is cool. It gives you the 4 marks, but it doesn't help you with the sum. The other one can help you. Okay, let's go. Normal. FG. Friction. And then I'm going to take that applied force and I'm going to make X and a Y component out of it.
Yeah.
That you've done with vectors as well.
Yes.
So let's just look at those values. If I make a triangle here, then this force here is 30 newtons. This is the Y component and this is the X component. Agreed?
Yes. Yes, I agree.
The X component is cos because cos of 20 is adjacent over hypotenuse. So
yes,
cos 20 is X. And similar, 30 sine 20 is Y. So people don't work that out. Students normally don't work that out. They just learn that the X component is the force cos the angle, and the y component is the force sin the angle.
All right.
Okay, so I'm going to delete this red one, or I'm just going to make it smaller, both of these. You can use both of them, or not both. You can't use both. You can use any one of them. Just push it to the side there. It doesn't want to. Okay, this side. Can you still see? Or is it too small?
Yes, I can. I can see.
So you normally work on a PC.
Yeah, I normally work on a PC.
So free body diagram was correct. Okay, now the next thing I want to know, what is the friction? The force of friction. Okay, very important. The frictional force, it's this one, yeah. The frictional force, you can determine the frictional kinetic force. It's K because the component is kinetic, is mu
Yes.
Kn. Now,
Okay.
this is where the blue free body diagram comes in handy, because the blue
Yeah.
diagram tells you that the normal force plus the y component equals the Fg force.
Yeah.
You look at that free body diagram. These three forces are in equilibrium.
Yes, I see that.
Okay, the normal plus, what's Fy? Fy is the force sin the 20. It's a force times sin the angle. And Fg is
Okay.
just mg. So
Yeah.
normal plus the force, which was 30 newtons, times sine 20 equals
Yeah.
mass. I don't know what that is. 5 kg times 9,8. So the normal
Okay.
force is 5 times 9.8 minus 30 sin 20.
Yeah.
And that is 38,739, whatever. So
Okay.
the frictional force is the coefficient of static or kinetic friction, 0,2 times
Yeah.
that answer. Again, I'm not going to type in the answer. I have the answer in my calculator, so I'm just going to times 0.2. So that saves me from rounding off too early.
Yeah.
7,7478. The frictional force is 7,75 newtons to the left.
Okay.
And the last bit they're going to ask, what is the acceleration?
All right. So we use F net equals MA.
F net equals MA.
And then we would say equals F plus negative F.
Fx, remember, I'm looking at these
Oh, yeah.
components.
Oh, yeah. Plus
That's why
negative.
the red diagram doesn't help anymore.
Yeah.
The force in the red diagram is not parallel to the surface, so you can't use that.
Yeah.
So that is Fx minus friction. You're supposed to write plus negative friction.
Yeah.
Is 5a. Okay, so the x component is cos. So that's the force cos alpha minus the friction we just got, 7,75. That is
Yeah.
5a. So the force applied was something like 30 newtons. Cos the angle of 20 minus 7,75. And that is 5a. That's just calculation from now. 30 sin 20.
It's cos.
Oh, it's cos.
Yeah.
Cos 20 minus 7.75 equals, divide by 5. 4,09
Yes.
meters per second squared to the right.
Yeah.
Okay. Right. We finished with these sums. We're not finished with this yet. I just want to use the last 10 minutes just to show you something.
Okay.
Okay. Let's assume that there's a surface with a slight angle. Let's say alpha.
Okay.
And there's a block.
Yeah.
Now, at the moment, if I draw a free body diagram, there's a normal force there. There's friction going that way. So let's say me equals 0.2. There's friction going that way, and there's a parallel force there, FG parallel, and then obviously FG perpendicular. But
Okay.
we're just going to focus on these two forces parallel to the surface.
All
Now,
right.
if the block's not moving, if it's static,
Yeah.
then those two forces are the same.
Okay.
Then, as you're lifting this surface up,
Yeah.
the angle increases.
Okay.
Then at a certain point, that box is going to start slipping and sliding down.
Yeah. It's going to start
When it
moving.
reaches its maximum, so when it's reaching the maximum Fs.
Yeah.
So in other words, the parallel force is going to increase. The friction is going to increase. As you're lifting that up, the friction becomes more and the parallel force becomes more, to a point where the parallel force is higher than the maximum friction the surface can offer. Then it slides down.
Yeah.
So if you have this surface, any angle, yeah, and you have a coefficient, say it's S, static, it's supposed to be called max
Yeah.
of 0.2, then we can calculate that angle. And the equation is tan alpha is me S. That is supposed to be max. So
Right.
tan alpha is 0.2. So now I just type in my calculator shift tan 0.2. And then you get 11,031. So alpha is 11,031. And if I round it off, it's not 0331.
3. Yeah.
So that's 11,31.
Yeah.
That's the maximum angle that I can lift it.
Okay. Yeah.
Okay. So now what you must realize is it's only at 11,31 that the maximum friction is that you get the maximum friction of the surface. Before that, the friction will be exactly the same as the parallel force.
Yeah.
So let's just do a quick example of this,
Okay.
just to illustrate that. So
Yeah.
I'm going to have a surface here, and
Yeah.
alpha there, and I'm going to have block there of 10 kg, keep it simple, and the coefficient of static friction, let's say, is 0,4.
Yeah.
So now, let's say alpha equals 15 degrees.
Yes.
Yeah. And the block is in rest.
Okay.
Then my free body diagram looks like this. Okay, we have a normal. We have
And then
friction. We have the
yes.
FG parallel. And we have the FG perpendicular force.
Yeah.
Then those two forces parallel to the surface are in equilibrium.
Yes.
So therefore F net is 0 because it's not moving, it's in rest. Then
Yeah.
let's use the downward force as positive. The friction is negative. I can put a little S there because it's static.
Yes.
Then the FG parallel equals Fs.
Yeah.
FG parallel is mg sine 15 because we've made
Yes.
alpha 15 degrees. And that
Yes.
is the frictional force. So
Okay.
mass 9,8
Yes.
sin 15 is the force of friction. So the frictional force is what? 98?
20.
Really? 25,36.
Yeah. That's what I got.
Good. But that's not necessarily the maximum friction. Because as you lift, the frictional force is just basically what a frictional force does. It's just a response to whatever force parallel is.
Okay.
So it's like something that's quite strong. And
Yeah.
the moment the parallel forces pulls down to 25 newtons, the friction just pulls back at 29. But it's just got a strength to a certain point.
Yeah.
So I can go and find out at what is the maximum friction. I can say the maximum friction static max, is mu s n. But this is only at the maximum angle. I can calculate that. Tan alpha is m. Not m. Me. Yes.
Okay.
So tan alpha is 0,4. So shift tan 0.4 is 21,8. So alpha is 21,801 degrees.
Okay.
That's the maximum angle it can use.
Go to.
So I can go back to this equation here and say the static friction is mg sine 21,801 or whatever.
Yeah.
So mass is 10, g is 9,8, and then sin of 21,801, whatever. So that's 98 sin answer, I think. 36,4. That's the maximum. That's the max, static friction max. Anything above that or similar to that in the box will slide.
Yeah. All right.
Okay, so we've done a bit of friction. We've played around with some Newton 2 stuff. If you haven't done a lot of this, you're a quick learner, which is good news.
Thank you.
But then it means that you will just need to get the tools to do some self-study as well. Or just, I don't know,
Of course.
I don't know why you're not on the ball then.
Okay.
Look, I'm going to tell you one thing about all textbooks and all stuff.
Yeah.
Your textbooks doesn't have enough examples in as it is. It just has homework in it.
Yeah.
You'll have to do your work.
Okay.
Right.
I can do that, yes.
What you can do is just also Google past papers.
Yeah.
Or I can send you stuff.
Okay. Thank you. Please do.
Okay. And then maybe you want to do something next week again, just let me know.
Yeah, of course. You must just let me know when you're free and
I'm normally not free, but I don't have homeschoolers at the moment because you're all on holiday next week. So next week, anytime I can see you till about 1 in the from let's say anything between 10 and 1 in the morning, I can see you.
Okay, cool.
I'm gonna know on what do you want on email stuff?
It's up to you. I don't really mind.
Okay, I'll send you a mail with various things on it. It's in Afrikaans.
Yeah.
But I think you'll find it easy to understand exactly what they want.
Okay.
Okay, Bianca, keep well.
Thank you so much.
No problem. Cheers. Bye-bye.
Bye.